Hello everyone. Let us look into the actual technicalities of Hadoop framework. Before that, let us look at the brief history of from where this Hadoop started and what is its journey so far. Hadoop, as the name given, high availability distributed object oriented platform. Concentrate on the words high availability, distributed, object oriented. These are the three key terms for Hadoop. High availability. Every time, all the time, the data is available. Distributed. The data is available on a network. Object oriented, we know the principles of object orientedness. So, Hadoop supports high availability, distribution of the data, object oriented patterns. So, let us go in deep of Hadoop. That is exactly what the technology is offering to developers, high availability via parallel distribution of object oriented tasks. So, everything when we are talking about Hadoop tasks, everything will be an object of the task. Now, let us talk about Apache Hadoop. It is an open source and Java based software. Entire Hadoop framework, the ecosystem, everything is written in Java, but it supports other languages also. Eventually we are going to talk about that also. So, Hadoop is coming from Apache, it is an open source and it is Java based. This platform is trying to provide two major things: storing the data and processing the data, and after processing it is supporting the analytics of the data also. Hadoop processes what type of data? It processes structured, unstructured, semi-structured. Because of all these features, Hadoop is becoming popular, or it has become popular. And it also supports one more important feature called scaling up. What exactly is scaling up? Suppose I am working with my laptop which is having, say for example, 500 GB of space. I want to increase the space of my system. I want to use more storage space. There are two possibilities: either I can attach extra hard disk space, or I can try to buy a high configuration system. In the first case, wherein to the existing system, if I am adding some more storage space, we call it as scaling up vertically. I did not change my system, I just changed, or I added some more components into that to increase its speed or increase its capacity. Existing system is modified, we call it as scaling up vertically. Horizontal scaling, to the existing systems I attach some more systems into the network without disturbing the existing systems. We call it as horizontal scaling. So, Hadoop network, or we also call it as Hadoop cluster, which supports both horizontal and vertical scaling. Because of this feature, it is more popular. Then, when was Hadoop actually started? It actually started somewhere in 2002 by two people, Doc Cutting and Mike Caffarella. These two people were working at Yahoo, and they were working on some project called Nudge. So, let us just quickly see what exactly is the journey of Hadoop so far. So, if you can see, let us see the journey of Hadoop. It started in 2002, wherein these two people started with a project called Nudge. And 2003, Google has released a paper called GFS, Google File System, which is, even today we call it as the base paper for Hadoop. And 2004, Google released a white paper on MapReduce, that is the processing component of Hadoop. Then in between this, Nudge is separated. Nudge was taking care of client server architectures and all, and MapReduce is separated from both of the things. Later in 2006, Hadoop started as a separate project, and 2007 Yahoo started working on a cluster which is built with 1000 nodes of the system. Then 2008, almost the first version of Hadoop is released by Apache, later rest of the versions, and now we are working with, from 2020 onwards, we are working with Hadoop 3.1.3. So, this is the journey of Hadoop so far. Then fine, Hadoop is coming into existence and it started, people started accepting that and it started catering to our needs of big data. What is the impact of working with Hadoop? What benefits does the industry is taking from this framework? Now, whenever we are trying to work with Hadoop, because it is giving us the features of storing huge data and processing huge data, first thing is it is very inexpensive because it is coming as an open source and it is able to work on off the shelf hardware. I need not have a high end configuration systems. I can work with a normal system in order to work with Hadoop framework. So I don't need to go for high end infrastructure. This is the first advantage. Second one, till that Hadoop was coming into picture and into operation, people used to work with data warehouse and data warehouse applications, which were only limited to some of the experts. But later, once Hadoop has come into picture, it has taken out all these things which are rigid formats, rigid algorithms, all these things have been ruled out by the existence of Hadoop. And also with the introduction of Hadoop, organizations have quick access to storage as well as processing elements of the system, which was not that easy when they were working with data warehousing concepts. Then how does Hadoop work? Hadoop is a framework which allows for the distribution of giant data sets across a cluster of commodity hardware. This is very important. We are trying to work with normal machines or commodity hardware on which we connect them via a network and the data is spread across this network of commodity hardware. So we are trying to store the data and Hadoop processing is performed in parallel on multiple servers simultaneously. We know the concepts of parallel programming. So Hadoop processing is taking advantage of parallel programming and multiple servers are working simultaneously. A huge task is given, so we try to break it into pieces. We don't sit there physically to break it into pieces. The server will break it into subtasks and it is spread to the servers. Each server will work with the subtask and the results are passed on. Then clients submit the data and programs to Hadoop. In simple terms, Hdfs, which is a core component, Hadoop Distributed File System, Hdfs, which handles both the file system as well as the metadata, the actual data of the system as well as metadata of the system. Whatever we have metadata, that is also maintained under Hdfs only. And it also has a processing component, MapReduce. So when you talk about Hadoop, we need to talk about storage and processing. Storage is taken care by Hdfs, processing is taken care by MapReduce. Finally, there is one more thing called as YARN, yet another resource negotiator. This YARN divides the tasks across the cluster. I will exactly show you what exactly YARN is doing. So with this Hadoop, clients can expect efficiency of commodity resources and high availability. This is very important and this is the core of Hadoop. And it also has one more feature called failure detection, which is built into it. So it can automatically detect which node is failing, how do I take care of that. All these features are automatically available with this. And clients can expect quick responses. Though we are dealing with huge amounts of data and huge processing requests, still the response time, the amount of time or the time between submission of the jobs and the first response, the response times will be very low. So you are going to get quick responses from the system. So in all these things put together, Hadoop provides a relatively easy solution for organizations which are trying to make most out of the big data. Which language Hadoop is written in? While talking about history, I told it's a Java based platform. So again I reiterate, Hadoop is a framework which is mostly written in Java, but it can also support C, C++, Python, Ruby, other languages also, right? Then what exactly is Hadoop ecosystem. Hadoop ecosystem comprises of two types of modules. First one, core Hadoop modules. Second one, sub-modules. So, who are there under core modules? Who are there under sub-modules? Let us quickly look at that. Under Hadoop core modules, we have Hdfs, Hadoop Distributed File System, yet another resource negotiator, in short we call it as YARN. The next one is MapReduce, which is the processing component, and Hadoop Common. So, I will talk about what exactly is this Hadoop Common. Apart from this, there are some more sub-modules also, which are Hive, Impala, Pig, Zookeeper, Flume, etc. These are only some of the sub-modules I am talking about. These are the core modules of Hadoop. First one is Hdfs. So, what exactly is Hdfs? Hadoop Distributed File System. This is the point where entire data along with the metadata will be maintained, right? This is the file system. Out of this Hdfs, Yahoo has contributed to 80% of Hdfs, whatever the implementation part of Hdfs. Coming to YARN, it exactly works similar to our normal operating system. If you see the activities that YARN is doing, YARN is used for cluster resource management, planning the tasks, scheduling the jobs, all these things, and running them on Hadoop also. So, YARN is trying to work similarly like an operating system. Operating system is used for resource allocation, operating system is used for scheduling the jobs. These are the major activities of operating system. So, YARN is working similar to operating system. This is the file system. This is taking care of scheduling the jobs and running the jobs and taking care of resource allocation. The third component is MapReduce. As I kept on talking, this is the actual processing component of Hadoop. Data is there, and unless I give a process, unless I give a execution, job execution, the data is of no use for us. So, this is where MapReduce comes into picture. This is the processing model of Hadoop framework. So, the last module of Hadoop core is Hadoop Common, which is providing set of services across the libraries and utilities to support the other Hadoop modules. So, this is like a common coordinator between various other modules of Hadoop framework. These are the sub modules of Hadoop ecosystem. So, we will be talking about Scoop, and we will be talking about Flume. Zookeeper is like a coordinator for the entire modules, and we will also be talking about MapReduce. We will be talking about Pig, and we will be talking about Hdfs. These are various frameworks which are supporting, so we call them as the sub modules of Hadoop framework. So, this is just a brief description of all the sub modules. Apache Hive, this is the data warehouse component of Hadoop framework. Impala, open source coming from Hadoop, which takes care of native analytic database. Pig is a tool which is used for analyzing the data, and Zookeeper, centralized service for enabling highly reliable distributed processing. Scoop is one more tool which will be used for transferring huge amounts of data between Apache Hadoop and RDBMS kind, structured database services. So, why we need to work with Hadoop? For few reasons. It is storing my big data. How does it store the big data? Say for example, I just have jotted down an example here. Suppose we have 512 MB of data, and I feel suppose this is very huge amounts of data. Suppose our Hdfs, while configuring, we have set each data block should not exceed more than 128 megabytes. In such cases, Hdfs will try to divide my whole file of 512 MB into 4 blocks and stores them across the data nodes. Whenever we are working with Hadoop cluster, there will be two types of nodes, data nodes and name nodes. I will be talking about what are data nodes and name nodes shortly, but as of now try to understand, if I want to store my huge file and the configuration is set to this one only, what happens is Hadoop will automatically divide your file into blocks and the blocks are spread across the network. Scalability, as I spoke about vertical and horizontal scalability, Hadoop automatically supports this without much disturbances. So, we go for scalability under Hadoop. And storing various types of data, Hadoop stores various types of data, and also whenever you are trying to store the data it also follows the model write once and read many times. And data processing speed, because of processing is distributed across a network, multiple nodes will be working on the question we posted, the processings will be done very fast. And because the data is going into distribution and the processing is also happening on distribution, we say this is following the principle called data locality. Thank you.